This problem, it gives you the x-intercepts. They are, a little brighter colors here, -3, 0. That would be this point right here. And then 4, 0, which is this point right here. And pink 6, 0 is this point right there. And if I set this equal, or like if I took these two terms and moved them to the other side, I'd have x cubed minus 7x squared minus 6x plus 72 is less than or equal to 0. I want to know where the function is less than or equal to 0. That means, this means less than or equal to 0 would be below the x-axis. We're looking at the part of the graph that is in quadrants 3 and 4. Quadrant 3 is this quadrant here, right? And quadrant 4 is this quadrant. And so when I'm looking at this picture, all of these points right here, this is the part of the graph, and it keeps going. All of those points on this cubic have y coordinates that are negative, that are less than or equal to 0. And since it does say equal to, I'm going to have to include that point. So for quadrant 3, we're looking at from -infinity up to the -3 and including it, and then union that with, it's a little harder to see, I'm going to put it in pink, but just this little piece right here between the green dot and the pink dot, just that little curve is in quadrant 4. And it isn't equal to, so I need brackets. So between the 4 and the 6. And so this is my answer to solving that inequality. Now, the very last question. Number 28. It says, list the critical values of the related function and solve the inequality. Okay. First of all, in order to solve the inequality, I have to have 0 on one side. So I would simply subtract 0, or subtract the 4 over. So that's going to make this x plus 25 over x plus 9 minus 4 is less than 0. Okay, so to find the critical values, I automatically see one of them. The denominator has an x in it, and that's where I'm going to have an asymptote. So x is equal to -9 is one of my critical values. That's one of them. The other one is where this thing actually equals 0. I know it says less than 0. I'm just going to leave it there, but solving this for x, when you set it equal to 0 and you solve it, you're looking for another critical value. So let's see. Let me rewrite it over here. I'm going to take this and set it equal to 0. And then I need to get rid of the fractions. So I'm going to multiply everything by an x plus 9. And of course, the x plus 9 cancels on this first one, so you'll just be left with the x plus 25. On the next one, I'm going to have to distribute the -4 to the x plus 9. So that's minus 4x minus 36. And then on the other side, 0 times anything, well, that's just 0. And then I'm going to combine like terms. So x and minus 4x is -3x. And then 25 and negative 36 is a negative 11. And I'm going to add 11 to the 0 and divide by negative 3. Divide by negative 3. There we go. So this is my other critical value. All right, so I got 2 critical values. So I'll call it, this is critical value number 1, critical value number 2. Now, keep in mind that the original function said less than. So we're wanting to know, where is this function below the x-axis? We're once again looking for, this means negative values for the y-coordinate. Now in this one, because I don't have a good visual on what this graph looks like, when I did this earlier, it was with a parabola, and I knew what a parabola looked like, but this one I'm not quite sure. So what we're going to have to do is create one of those little number line table things. Hang on a second here. Hopefully I'm not going to run out of time. Yeah, I'm good. Okay, so on a number line, our critical values were a negative 9 and a negative 11/3. So negative 9 is smaller than negative 11/3, because negative 11/3 is really what? Negative 3 2/3? Okay, so this thing is divided up into 3 intervals. This one here from this, this one goes from negative infinity up to negative 9, and there was no equal to on this, so it's parenthesis. That's that interval. And then we've got this interval in between, so this interval would be written as negative 9 to negative 11/3. And then we've got this interval, and that interval would be from the negative 11/3 to infinity. And yeah. Okay, so I have to figure out, you have to pick a test point. Pick a point, any point, somewhere in the yellow, somewhere in the pink, and somewhere in the blue. Plug it into the function and see, does the answer come out to be positive or does it come out to be negative? So I can keep this, kosher here. For the yellow, I'm gonna pick, what did I pick? I picked negative 10. I just picked x equals negative 10. And then the original function was x plus 25, so negative 10 plus 25 over x plus 9, so negative 10 plus 9, and then you got minus 4. That's what f of x would be. Let's see, that's going to be positive 15 over negative 1 minus 4. So I've got a negative 15 minus 4, which is a negative 19. So this, since this is negative, that is less than 0. So I know that this first interval is part of my answer. Now let's go to the next interval, which is in pink, and just pick some number between negative 9 and negative 3 2/3, and I just picked 5, negative 5. For some reason I picked negative 5. So this is going to be negative 5 plus 25 over negative 5 plus 9 minus 4, which is 20 over negative 5 plus 9 is 4, which is 5, and 5 minus 4 is a 1. And 1 is actually